Welcome to clickmyproject.com. Our product title is Design of a Unified Power Controller for Variable Speed Fixed Pitch Wind Energy Conversion System. Let us see about the abstract of our product. In this implementation is designed as per this above block diagram. In MATLAB wind turbine block is there, so we put the plug in the corresponding design module file. After that we design the diode rectifier using of diodes. Output of the diode rectifier is fed into the DC link capacitor. Here we measure the voltage across the link and current through that link. That current and voltage is fed into MPPT algorithm. Here that algorithm is developed in MATLAB function file. In that algorithm is produced duty cycle. After that duty cycle is fed into the PWM generator. The purpose of PWM generator is produce the pulse signal. This generator pulse is fed into modified boost converter. The generator pulse circuit switching gates. Here the distorted DC voltage is boosted into a constant DC value. Finally that DC voltage is fed into the DC bus. One important thing, the output of DC voltage takes several times to attain constant value due to passive element. Next we see about the flow diagram of our process. In this flow diagram, the wind turbine is a permanent minus synchronous generator, and that wind turbine is generate the AC voltage. Then that voltage is fed into the diode rectifier. Using of diode rectifier that convert the AC to DC, and also that not record any pulses because the diode rectifier not giving the gate terminal. So but it is not a controlled rectifier. This is an uncontrolled rectifier, and the output of the conversion DC is fed into the boost converter. The boost converter function is boosted the value from the output of diode rectifier, and that boosted value is fed into the DC bus, and DC bus is fed into the load. In between, the boost converter is controlled by using of MPPT controller. So MPPT controller is nothing but that getting the voltage and current, and also that having the flow chart. As per the flow chart we are writing the coding, and then that MPPT produce a duty ratio. From that duty ratio is fed into the PWM generator. That PWM generator is fed into the boost converter. Power electronic switches. That triggered power electronic switches is boosting the voltage from that DC voltage to another boosted level. So finally that voltage is fed into DC bus. In the DC bus is connected to the load. That load is maybe a resistive or inductive or capacitive load. Here we using resistive load. So using of resistive load, the voltage and current is measured by using of the measurement devices. In the PMSG having some parameters housing stator values, that PMSG generator speed, then and corresponding stator current, voltage, and so on. So those are all measured by using of the scopes, and corresponding scopes is connected in the corresponding areas. And finally then the diode rectifier output also measured by using of voltage and current measurements. In the input side we using 3-phase voltage and current measurement. Using of 3-phase voltage and current measurement, which kind of value we want to show, and also here we change the base to base voltage or base to ground voltage, we can change that, and also corresponding output can be so in the output scopes. And also in the boost converter we using voltage and current waveform in the input side and also the output side. So corresponding waveform will be shown in the corresponding scopes. And in the load side we connecting one voltmeter and ammeter, so corresponding output will be shown in that. Next we see about running process of our product. In this proposed implementation we did in the MATLAB simulating environment. First open the MATLAB main window and create a new model file. After creating that, we are arranging the elements from simulating library browser as per the given flow diagram. After arranging that, the mainly in simulating library browser to using two kind of blocks. One is the SimPower system, another one is the commonly used block. From that blocks we getting the elements and that arranging as per the given flow diagram. After that we get the scope from the commonly used block. So then connect the corresponding measurement devices across, then the corresponding scopes will be connected. After that we click the run icon. Then the simulation will start to run. Then when the simulation is entered, then open the scopes, the corresponding output will be shown. The first one is the VDC and omega hour, that is the wind DC link voltage and the speed and the real and reactive power output, and this is the pitch. This next one is the mechanical torque and the electromechanical torque. Next one is the turbine speed, and then this is the IABC grid voltage, VABC, and also rotor current and rotor voltage, and also stator current and stator voltage. This is the wind speed of the wind. Next one is the output DC voltage, and this is the MOSFET voltage and current characteristics, and is generated in the pulses waveform, and this is the output DC voltage waveform. Here we can see the output voltage is 1250 voltage DC voltage, and next one is the current waveform. This is 12.5 amps. So we here the connecting load is the resistive load, so the resistance value is 100 ohms. So corresponding the current will be drawn using of resistance load. So overall the circuit design will be regulation. Thank you for watching this video.